Today we start lecture number 7, okay, TCP/IP model. So TCP/IP model. So TCP/IP model was developed prior to the OSI model. You know well everyone to OSI model, okay. So the TCP/IP model is not exactly similar to the OSI model. The TCP/IP model consists of 5 layers, okay. In OSI model, there is a 7 layer, okay, but consist of 5 layer is application layer, transport layer, network layer, data link layer, and physical layer. The first 4 layers provide physical standards, network interface, internetworking, and transport functions that correspond to the first 4 layers of the OSI model. And these 4 layers are represented in TCP/IP model by a single layer called the application layer. Then TCP/IP is a hierarchical protocol made up interactive modules and each of them provides specific functionality. See the function chart of TCP/IP layer. Okay. So see the first one is a physical layer and data link layer. Okay. After that, network. In network, ICMP, IGMP, IP, ARP, and RRRP. So third layer is a network layer. In that, ICMP means Internet Control Message Protocol. Okay. Then IGMP, Internet Group Message Protocol. IP, Internet Protocol. ARP means storage of MAC address. RARP means routing table. Okay. So these are concept of network layer, ICMP, IGMP, IP, ARP, and RARP. So ICMP means when you ping your destinations like www.yahoo.com or your gateway, router gateway 192.168.2.1, then you ping that gateway or IP address, then you then you have to display a reply from 192.168.1.1, 32 ms, 10 ms, 5 ms. So that is a ICMP packets. Okay, you send to source to destination. Same scenario in this is ICMP used in broadcast network and IGMP packets used in multicast network. Okay. So IGMP union used in multicast network. So you know IP address is the same. ARP table means storage of MAC address in your layer 2, layer 3 switches. Okay. Then RARP, that is a routing RP, routing table. So routing table is used in router. Okay. So layer 2 and layer 3 switches different and router also different. Okay. So in router works IP address and MAC address entry in RARP. Okay. After that, transport layer. So in transport layer, there is a two parts. One is a TCP, then UDP. Okay. Then fifth layer is session layer, presentation layer, and application layer. See, these are combined layer that SMTP, FTP, Telnet, DNS, SNTP, RPC, TFTP. Okay, so these are applications. So anyone know about SMTP, FTP, Telnet, SNMP? Anyone knows?
Sir, SNMP is a simple network protocol. It is
Okay,
basically used to collect device information. I mean, like if some device supports SNMP, so we can take the information from that device. So that is why we use SNMP.
yes, correct. So that is an application. Okay, so similarly, also Telnet. We also all used to Telnet. Okay, so Telnet also same application. Okay, FTP also application and SMTP also application. So anyone knows SMTP protocol?
Mail transfer protocol, sir. We send mails.
Yes. Okay. So this protocol used in mail addressing. Okay. Incoming and outgoing. Okay.
Yes, sir.
So yes. So these are application. Okay. So these all application is work with this TCP/IP layer. Okay. So point is clear. What is a TCP/IP model? What is the structure of TCP/IP model? How to flow? Okay. So this is a your network, your packet flow. How to your packet source to destination. Okay. Point is clear. Okay. So network access layer. A network layer is the lowest layer of the TCP/IP model. Okay. The network TCP/IP model is a main working layer with a working layer is network layer. Okay. Then a network layer is a combination of the physical layer and data link layer defined in the OSI reference model. It defines how the data should be sent physically through the network. Okay. Then this layer is mainly responsible for the transmission of the data between two devices on the same network. The functions carried out by this layer are encapsulating the data IP datagram into frames transmitted by the network and mapping of the IP address into physical address. There is a some encapsulating IP datagram. Okay. The protocol used by this layer are Ethernet token ring frame relay X25. Okay, this is Ethernet token ring. This is a data link layers. Some protocols. So after network layer, internet layer. An internet layer is a second layer of TCP/IP model. An internet layer is also known as a network layer. We also call to this to internet layer to network layer. The main responsibility of the internet layer is to send the packets from any network and they arrive at the destination irrespective of the route they take. Okay. So following are the protocol used in layers are IP protocol. IP protocol is used this layer and it is most significant part of entire TCP IP suites. See IP protocol. So IP protocols IP addressing. This protocol implements logical host addresses known as IP addresses. The IP addresses are used by the internet and higher layers to identify the device and to provide internetworking routing. Okay. Then host to host communication. It determines the path through which data is to transmitted. After that, data encapsulation and formatting. An IP protocol accepts the data from the transport layer protocol. An IP protocol ensures that the data is sent and received securely. It encapsulates the data into messages known as IP datagram. Fourth one is fragmentation and disassembly. The limit imposed on the size of IP datagram by data link layer protocol is known as maximum transmission unit, that called MTU. So MTU size has a difference 1400, 1500, 1600, also 1900. So depends on layer 2 and layer 3 switches capacity. So there is some MTU capacity of their storage. If the size of IP datagram is greater than MTU unit, then the IP protocol splits the datagram into smaller units so that they can travel over the local network. Fragmentation can be done by the sender or intermediate router. At the receiver side, all the fragments are reassembled to form an original message. So that work is MTU. Routing. When IP datagram is sent over the same local network, such as LAN, MAN, WAN, is known as directly delivery. When source and destination are on the desired network, then IP datagram is sent indirectly. This can be accomplished by routing the IP datagram through various devices such as a router. So LAN is a small local area network. MAN is a metro area network. WAN means mostly in, internet ISP network. Okay. MAN is a metro area network, which is a city network. And LAN is basically called enterprise network that many offices use this LAN network. Okay. So here is a three different network. Okay, so here is the two terms mainly associated with the ARP protocol. Okay, so ARP protocol, first is ARP request, then ARP reply. When the sender wants to know physical address of the device, it broadcasts a ARP request to the network. Okay, so PC1 send to request to PC2 IP address. Okay, via layer 2 switch. So they are connected with Cat6 cable with physical address. So they first request they are broadcasting to layer 2 switch. Okay. So that PC1 MAC address stored on that layer 2 switch. Okay. Then ARP reply. Every device attached to the network will accept the ARP request and process the request. But only recipient recognizes the IP address and sends back its physical address in the form of ARP reply. The recipient's address is the physical address both to cache memory and the datagram header. Okay, so that is the ARP request and ARP reply. After that, ICMP protocol. So ICMP stands for the Internet Control Message Protocol. It is a mechanism used by a host or router to send notification regarding datagram problems back to the sender. A datagram travels from router to router until it reaches its destination. If a router is unable to route the data because of some unusual conditions, such as disabled links, a device on fire or network congestions, then the ICMP patrol is used to inform the sender that datagram is unavailable. So that scenario, your Cat 6 cable is damaged, your optical fiber is damaged. Otherwise, your SFP module is also damaged. Any power supply issues. Okay, so that time ICMP protocol undeliverable. So an ICMP protocol is mainly uses two terms. Okay, so ICMP test and ICMP reply. ICMP test is used to test whether a destination is reachable or not. Okay, so that IP address is reachable or not. That is a ICMP test. Then ICMP reply. ICMP reply is used to check whether the destination device is responding or not. That is a ICMP reply. The core responsibility of the ICMP protocol is to report the problems, not correct them. The responsibility of the correction lies with the sender. ICMP can send the message only to the source but not to the intermediate router
Sir,
because the
ICMP reply is depends on ICMP test.
yes, ICMP is a that your reply testing. Okay, so that your request and that IP address, that ICMP reply means your reply 192.168.1.1 8.8.8. Okay, or that comes with MS. Okay,
ICMP reply only is only applied after the ICMP test.
yes. First
Okay.
is a test, then reply. Okay. See, PC1 sends some ICMP test. Okay, but there is some your PC1 to PC2 connectivity is a drop or some issues. Okay, or unplugged. So that time ICMP test is okay, but there is no any reply coming from PC2. Okay, so that time you message getting request time out. Okay,
Okay, sir.
yes. So the transport layer. The transport layer is responsible for the reliability, flow control, and correction of data which is being sent over the network. There are two protocols used in transport layer. Okay, user datagram protocol and transmission control protocol. UDP and TCP. So, however, user datagram protocol it provides connectionless service and end-to-end delivery of transmission. It is an unreliable protocol as it discovers the errors but not specify the error. User datagram protocol discovers the error and ICMP protocol reports the error the sender that user datagram has been damaged. So UDP consists of the following fields: source port address. The source port address is the address of the application program that has created the message. Destination port address. The destination port address is the address of the application program that receives the message. Then total length, it defines the total number of bytes user datagram in bytes. Okay. Then checksum. The checksum is 16-bit field used in error detection. So the UDP transport layer is a very unreliable, very slow process, error process. They are not used in our transport layer. So basically, mostly we use TCP methods, transmission control protocol. Okay, so mostly we use TCP. See, this is the variable 8 bytes. This is a header, this is a data header format. So in header format, source port address is a 16-bit. Okay, then total is 16, total it is 16 bits. After that, destination port also 16 bits. Okay, and here is a some checksum 16 bits. Okay, so that is checksum bits means verify the corrections data correct or not. Okay, so that is a checksum field. But in transmission control protocol, it provides a full transport layer services to application. Okay, then it creates a virtual circuit between the sender and receiver, and it is active for the duration of the transmission. TCP is a reliable protocol as it detects the error and retransmit the damaged frames. Therefore, it ensures all the segments must be received and acknowledged before the transmission is considered to be completed and a virtual circuit is discarded. At the sending end, TCP divides the whole message into smaller units known as a segment, and each segment contains a sequence number which is required for reordering the frames to form an original message. At the receiving end, TCP collects all the segments and records them based on the sequence numbers. So
Sir,
TCP,
how it detects the error?
no, in TCP method, there is no any errors getting. Okay, when errors getting, when your physical connectivity is damaged or some breaking or your device's power supply is down. Okay, so that cases getting error on TCP methods. Okay,
Okay.
so after application layer, this an application layer is a topmost layer in the TCP/IP model. It is a responsible is it is a responsible for handling high-level protocol issue representation. This layer allows the user to interact with the application. Okay. When one application layer protocol wants to communicate with another application layer, it towards its data to the transport layer. There is an ambiguity occurs in the application layer. Every application cannot be placed inside the application layer except those who interact with the communication system. For example, text editor cannot be considered in application layer while web browser using HTTP protocol to interact with the network where HTTP protocol is an application layer protocol. Okay, so many application very well. See, here is some applications. So first is HTTP. HTTP stands for Hypertext Transfer Protocol. This protocol allows us to access the data over the World Wide Web. It transfers the data in form of plain text, audio, video. It is known as a hypertext transfer protocol as it has the efficiency to use a hypertext environment where there are rapid jumps from one document to another. Okay, so HTTP is old, so now many websites are work with HTTPS. Okay, so HTTPS is a secure application. So many latest website work with that. HTTPS. Then SNMP. SNMP stands for a Simple Network Management Protocol. It is a framework used managing the devices on the internet by using TCP/IP protocol suite. SMTP. SMTP stands for a Simple Mail Transfer Protocol. The TCP/IP protocol that supports email is known as well Simple Mail transfer protocol. This protocol is used to send the data to another email address. After that, DNS. So DNS stand for a domain name system is an IP address used to identify the connection of host to the internet uniquely. But people prefer to use the names instead of address. Therefore, the system that maps are the name to the address is known as domain name system. So DNS is a main, it's a particular domain. Okay, so you using internet. Okay, so you using internet, so you browsing some many websites, but that website's main domain is a Google. So you need to mention every time DNS Google DNS IP address 8.8.8. Or 4.2.2.2, otherwise 8.8.4.4. So basically three DNS of this google.com. Okay. After that, telnet. It is an observation for terminal network. It establishes the connection between the local computer and remote computer in such a way that the local terminal appears to be terminal at the remote system. Okay. So telnet means you reach to your remote desktop, remote laptop, remote device, remote router. Okay. Any networking devices. Then FTP. FTP stands for the file transfer protocol. FTP is a standard internet protocol used transmitting the files from one computer to another. Okay. So these FTP protocols used for this file transferring. So point is clear about the HTTP, SNMP, SMTP, DNS, Telnet, FTP.
Yes, sir.
Okay.
Yes,
So,
sir.
so your packets, so your laptop, your desktop, okay, your server. When you send one packets to your different PC or different server, okay. So that also HTTP, SNMP, SMTP, DNS, Telnet, FTP. So this is the process working with this TCP/IP model. See the working of the TCP protocol. This is a client PC. This is a server PC. So client segment, okay, SYN segment to the server. Then server SYN plus acknowledgement. Okay. Then uh, client check the what is a sync message, okay, and what is a acknowledge segment. So then what he do, he provide acknowledgement segment to server. So this is a working of TCP protocol. This is a request. This is a handshake. Proper handshake means session is complete. Okay, so TCP/IP model is clear. Again, see the chart. Physical data link, then network SMP, IGMP, okay, then transport TCP, then you get SMTP, FTP, telnet. Okay, so point is clear.
Yes, sir. Yes,
Okay,
sir.
Okay, so now log in your layer 2 alphabet switch now. Username admin and password admin. Okay.
Done, sir.
Login that switch.
Yes, sir.
Okay, so just a wait. Okay, so please share your screen.
Yes, sir.
Okay. So so from your laptop, okay. So you reached with this 192.168 set 4.1, okay. That switch, correct?
Yes, sir.
Okay, so via which software? Qt.
Putty.
And via which method?
Tagnet.
Okay. So this all process is a TCP IP model. Okay. This is a whole process. Correct.
Yes, sir.
So in TCP IP model, your connectivity is your PC to switch. That is a Cat6 cable. Okay. So that Cat6 cable, can you remove that Cat6 cable?
Yes, sir.
Okay, so okay, remove. So see what error is receiving in your laptop?
Network error.
You-
Software call.
Okay, so software calls connection abort. Okay, so this error. So your TCP, this is your TCP IP model process is down. Correct? You got it. The how to break this network.
And
Clear the TCP IP process. Okay, so connect again that cable.
yes, sir.
Cable connect. No, no. For okay, cable connected.
Yes, sir. Connected, sir.
Yes. So now for so you now first ping that destination IP address. Okay. So which your destination IP address?
92 dot.
Huh. Okay. your destination IP address. Okay, so you first ICMP packets, okay, the ICMP packets first you test it, okay, then from reply, okay. So what reply? Reply from 192.168.4.1, correct?
Yes, sir.
Okay, so we remove again that cable.
Yes, sir. Remove that.
Okay, so now you again request for ping that destination IP address. That is request timeout. Okay. Clear the ICMP packets flow. Sriram, Karthik.
Yes, sir.
Okay. Karthik.
Yes, sir.
Okay. So this ICMP protocol used in use this process with TCP/IP. Okay.